Welcome to Vectors. This is day one on Vectors, and this is basically going through a few things that are really just clarifying for you, because a lot of you are already familiar with vectors, what we mean when we ask for certain things, what the particular notations mean, etc. So first of all, a vector is a directed line segment, meaning it has both magnitude or length and direction. That's as opposed to like a segment, which doesn't have any direction, or a ray, which keeps going on forever and doesn't have any length. A vector stops. It has an initial point and a terminal point. The initial point is where it starts. So for instance, on this one down here, the initial point is 1, 4, and then the terminal point is 3, negative 1. So this goes from 1, 4 to 3, negative 1, not backwards. It has a certain direction, and it only goes that direction. So first off, if you're asked if two vectors are equal or not, you have to show that the two things that define them, magnitude and direction, either are equal or are not equal. So that means we have to find the magnitude of both of these, which we write this way, and we have to find the direction. So here's some of the work we did finding the magnitude and direction on both of these. Looked like this. And I'm not going to go through everything here just because that would take an entire class period, but just kind of summarizing what we had in the notes. All right, next, we talked about component form. Component form is basically breaking down a vector into its horizontal component and its vertical component. And you can have negatives on this. When we use those components in the distance formula or Pythagorean theorem, negatives don't matter. That's why this doesn't have a negative on it, because I'm going to square it. But if you're going down, then yes, that's a negative 2. If you're going to the left, that would be negative as well. So this is 3 to the right, down 2. One way you can think of this is it's a little bit like a translation when you did rotations, reflections, etc. in geometry. Okay, so down here, this is another way of describing these with another notation. And we're just going to come back to that in a little bit. But this is component form right up here. You do need to make sure you have these. They're not parentheses. Okay, let's see. Here was an example we did. Find the component form and magnitude, and here's the work for that one. Okay, and here's another example. This one right here. And here's the work for that one. Okay, we were not asked about direction in either one of those, so we didn't find direction. Next, operations with vectors. You add them, subtract them, multiply a number times them, just the same way we do with matrices. You're also going to multiply them times each other, kind of like the way we do with matrices, but we're not doing that yet. Okay, so when we did this, we got the following answers right here. Next, we have a thing called a unit vector. A unit vector is a vector of magnitude 1. Fifth period, I skipped over this part right here. We're going to come back to it in a second. If I want to find a unit vector in the direction of a particular vector, that's what you'll be asked. It'll say, find a unit vector in the direction of, and then it gives you a vector. We have a formula. The formula is really simple. It's not really even deserving of the name formula. It's just take your vector, divide by its magnitude. So I have to find the magnitude of it and divide by that. Now what that usually means is getting radicals in the denominator, so then you end up having to rationalize your denominator. So here I found the magnitude of u, and then I divided each component by that magnitude, and then I rationalized. So this is the unit vector in the direction of u. Okay, we ran out of time a little bit on this one, but you can also do it for this one. And the answer you should get on that is this vector. For negative 5, 1, this is the unit vector in the direction of this vector u. Okay, can you prove it? Well, you should be able to. If you take a unit vector, to prove it's a unit vector, just like Pythagorean theorem or distance formula, this squared plus this squared, take the square root. In other words, find the magnitude of it, and you should get 1. And that's it.